All right, welcome. We're taking a look today at solving systems using substitution. So what we're going to be doing is doing two things. We're going to graph our solution here, okay? And we're going to solve it using substitution algebraically. All right, so let's do the graphing part first. We have the first equation, we have y equals 2x plus 1. And then the other equation here, we have x minus y is equal to 7. So if I'm solving for y here, okay, we would normally do that right here. Okay, we would normally get y by itself, so we can add y to both sides and get x equals 7 plus y. Subtract the 7 from both sides, and x minus 7 equals y. So the slope here is going to be 1, and the y-intercept is negative 7. And from the first equation, right, we know we're following that y equals mx plus b format. So the number in front of the x here, which is 1, is their slope. Here, the number in front of the x is 2, and the y-intercept is 1. So we're going to put a dot for the first line we have here at 1, and then use our slope of up 1 over 2. Sorry, up 2 over 1, so our slope of 2. Or down to left 1. So we get our positive slope here. And then we can go ahead and take our line and draw that in. And you can do this with your straight edge there. And there's our first line, and we want to go ahead and make sure we state the equation. Okay, second line, same thing. So the slope, the y-intercept here is 1. Sorry, is negative 7. 1, 2, 3, 4, 5, 6, 7. And we're going down 1 over 1. And we can see about where they're going to cross there. So we'll use our line again. All right. And if we extended this out, we get the basic idea here of where they're going to intersect. And you can see that they're going to cross down there at that point right there. So remember, we want to make sure we label a solution. Here we're off the graph, so we would want to make sure we change our scale. But the most important thing here is just graphing the line here. Okay. But we want to really focus on the algebra part here. So for algebraically, when we do substitution, okay, we are going to look at our two equations. What our goal is to take one of the equations and to solve for either x or y first, okay? In our first equation, that's done. We have it y equals. So I already know what the value of y is. So what I'm going to do then is look at my second equation, and I'm going to plug that solution, okay, into the second equation. So here where it says y, okay, I'm going to take the value of y, which we know is 2x plus 1, and I'm going to substitute that in. So what it looks like is x minus, parentheses, 2x minus 1 equals 7. So everything stays the same. I'm just substituting this value in for that variable that we solved for. Now I'm going to solve this equation, and that will give me the value of x, okay, the x coordinate from the intersection. So we're going to go ahead and distribute the negative 1. So I get x minus 2x minus 1 equals 7. So I combine like terms to get negative x minus 1 equals 7. Add 1 to both sides to get negative x is equal to 8. And then remember there's still a negative 1 in front we're going to divide out by. We get x equals negative 8. Now my job is to figure out the y coordinate. So in one of my two original equations, whatever's easier, we're going to plug this value of x in. So right here, we have y equals 2 times negative 8 plus 1. So this is negative 16 plus 1, and we know the y value is negative 15. So the solution, remember, it's a point. Where do these meet? They meet at the point negative 8, negative 15. They meet right there. So we're going to make sure when we're done, we write our answer as a point. And that's it. That's substitution. Okay? So let's try the second one here. So let's go ahead and graph it. So do that first. Okay, all right, so the slope, once again, is 4, or 4 over 1, up 4, right 1, down 4, left 1, and the y-intercept is -1, okay? So we're going to go up 4 over 1, or down 4, left 1, okay? And then now that we have our line, go ahead and draw that in for ourselves. All right, label our equation. And then the second line we already have done. So the slope is -1/2. So down 1, right 2, up 1, left 2. Okay. And the y-intercept is 8. Down 1, right, left, right 2. So you can already see what points they have in common. We can go ahead and draw our line in here. Double-sided line. All right, make sure we state the equation. And then we state our solution. Okay. So this is the point 2, 7. And now we're going to do it algebraically. So once again, we already know what y is, okay? So in the first equation, we know y equals -4x minus 1. Substitute that into the. So we got 4x minus 1. What I'm going to do is write down the original for a second. So hold on. Y equals -1/2 x plus 8. Careful. And then plug this in now. So 4x minus 1 equals -1/2 x plus 8. So remember, what we do is we're going to get rid of the denominator by multiplying both sides by 2. Okay, everything gets multiplied by 2. So we have 8x minus 2 is equal to 2 times a half is 1, so -1x plus 16. And now we're going to get x on both sides. So I'm going to add 1x to both sides. So 9x minus 2 is equal to 16. We'll add that 2 back to the other side. Get 9x is equal to 18. And then we can divide by 9, and we'll get x is equal to 2. So there's our 2 from the solution. Now I need to go figure out y. So we're going to go y equals 4x minus 1. It doesn't matter what equation you pick. We're just going to pick one of them from the original and plug 2 in. The reason we're using that equation and not one we solved for, which is the original, is because if we make a mistake, this will help catch it. So y equals 4 times 2 minus 1. 4 times 2 is 8, and 8 minus 1 is 7. Okay, and there's my 0.27. And then always, 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 we write our solution as a point when we're done. Okay. All right, let's try this third one for ourselves. 1. All right, so if you take a look at the next question, we're going to go ahead and graph it and solve for y. So let's do that first. So we're going to take our first equation, which is 2x plus y equals 4. Okay, so what we normally do, remember, to solve for y, so subtract 2x from both sides. And I'm going to get y equals -2x plus 4. Now, no, we don't want to do that. We don't want to do that. We don't want to do it. 3, 2, 1. All right, taking a look at this next question, what I'm going to notice here is that I want to use substitution. Now, how do I recognize when looking at the system that I want to use substitution? Number one, okay, you can see that this y, one of the variables, is very easy to solve for. There's no coefficient in front. So with a quick subtraction, I can get this by itself. Okay, so with substitution, if you have a variable that you can easily solve for, that's when we want to use substitution. If I was just looking at the bottom equation here, okay, ignoring the top, this one is going to be a little bit tougher to get it just y equals or x equals, because I'm going to end up with a fraction, and I don't like fractions when I'm doing systems, okay, as much. So if we take the first equation, we want to get y by itself. So we have 2x plus y equals 4. We can easily do that by subtracting 2x from both sides and getting y equals -2x plus 4. Okay, So now, remember, now that we know what y is, in the second equation, wherever we see a y, we're going to replace it with negative 2x plus 4. It's going to go right in for that y. So we're going to write down 2x plus 3 times negative 2x plus 4 equals 9. Okay? Then, remember, we're going to solve. We're just going to go ahead and distribute the 3. So 2x, 3 times negative 2 is negative 6x. 3 times 4 is 12 equals 9. So we can combine like terms here. We get negative 4x plus 12 equals 9. So subtract 12. We'll get negative 4x equals negative 3. And then we can divide by the negative 4 here and get x is equal to 0.75. That's 3/4. 5, not 3. Okay? Now, when I want to solve and figure out what y is, I'm going to go ahead and plug back in one of these two easy equations. We're going to do that right to the top here. So I have 2x plus y equals 4. I was going to pick an original because if I made a mistake in solving here, I won't catch the mistake. Okay, so I always want to plug back into the original. So it's 2 times 0.75 plus y equals 4. So this is 1.5. And then we subtract 1.5 from both sides. And we're going to get y equals 2.5. Okay? And if we wanted to do it graphically, we could. So we could graph our first line here. You can go ahead and do that for yourself, and you can see where they cross. But remember, the last step here is to go ahead and write this as a point. So it's 0.75 or 3/4, comma 2.5, or 5/2. And that's it. We're done. Okay? All right, let's go to the next one. So we have 3x plus y equals 5 and 3x plus y equals 8. So we want to use substitution because we can easily get this y value by itself in the equation. We would subtract 3x to do so. So I get y equals 8 minus 3x. So now in the top equation, wherever I see the y, I'm going to plug in that 8 minus 3x. So we have 3x plus y equals 5. So 3x plus 8 minus 3x equals 5. Now, these three x's have opposite signs. They're going to drop out and give me 0. So I just get 8 equals 5, which is not true. So remember, if we end up with an equation that's not true, our answer is no solution. Okay? And the reason is because if you look at our equations, we have 3x plus y equals 5. If we subtracted 3x from both sides, right, what do we notice? We get y equals negative 3x plus 5. And if we look at the second equation, 3x plus y equals 8, right? When we subtract 3x from both sides so that we can graph this, we're going to get y equals negative 3x plus 8. These slopes are both the same. So that means when I graph my line, okay, here's 8, and I go down 3, right 1, right 1, down 3, right 1, down 3, right 1, okay, I'm going to end up getting this line. All right. And then when I graph the second line, which is going through 5, all right, so it's at 5, and we're still going down 3 over 1. You can get the idea, up 3, right 1, that our lines actually don't cross, right? They run parallel to one another. And you can see that these lines are not going to cross. So that's how we know there's no solution here, okay? So if you were doing it graphically, we would want to graph our lines, label the equations, and then just write no solution on the graph, okay? Because the slopes are the same. And when you do it algebraically, when you get this to happen, right, we still put no solution. We show that these aren't equal. We put no solution. Okay, so that's it for today. All right. So what I want you guys to do is finish this last graph on your own. Okay, and then you can start working on your homework. This is in the no packet. You should have grabbed it when you. If you don't have a packet, it's over in front of the crate on the table. Okay. And then I want you to work on number 2, B, and D here. Okay, and this is on page 5. We'll see you guys tomorrow. Have a good day.